like I said, I'm going to call this a crash course. We're doing a crash course today. We're doing a crash course on Thursday. Crash course is Maya? It's kind of a random lesson, okay? A random lesson out of the blue. Parker?
It's like tests, about maybe something to do or to try.
Yeah, so these are newer skills. If you look at the first one on coordinate planes, we've already discussed coordinate planes. But the bottom thing, the box and whisker plots, is brand new. But it's just something that I'm trying to introduce you to. I can't teach you its entirety in one day in 40 minutes. But I'm going to throw enough at you where if you see something like this, you'll have a better idea of how to do it. Kind of like the statistical questions. Okay, if I wouldn't have talked to you about statistical questions, you'd have no idea what one was. But now that we spent like a day on it, I feel like you guys are pretty comfortable with it. Okay, so there are 3 different skills I'm going to touch on this week. Coordinate planes with 4 quadrants, box and whisker plots, and then on Thursday we're doing graphing inequalities and just inequalities in general, what they are. Okay, so for the notes, last year and some this year we've had coordinate planes with 4 quadrants. Which quadrant did we work with all of last year? If you look at your picture, which quadrant did we stay in last year? Finley? Quadrant 1, which I'm going to highlight mine up here. Okay, right there is our x and y axis. They're clearly labeled. And quadrant 1 is where we stayed last year. That's where all the positive numbers are. Okay? But no matter how many quadrants we're working with, the way we plot points is exactly the same. What do we use to put points on a coordinate plane? Who remembers what those things are called? They are numbers, but what are they called when I have a parentheses, number, comma, number? Kendall? Reese? The y and x axis are the lines that create the coordinate plane. They're the 2 number lines that we use to create the coordinate plane. Cam? Ordered pairs. An ordered pair gives the location on a coordinate plane. Okay? If you notice, where is 0, 0? Where is the origin? Where is the origin on here? Paxton? Right in the middle. Right in the center. I want us to kind of go out, draw a dot there. Draw a dot right there at the origin, and then draw a line out here and right, that is the origin, and the ordered pair is 0, 0. That's kind of where our 2 number lines intersect. And if you kind of use what you know about number lines and integers, if I look at the vertical number line, the one that goes up and down, if I start at that 0, where are the positive numbers? Emmett? Above it. Okay, how do I get to the negative numbers on that vertical? You go below it. What about on the x-axis? Where are the positive numbers? Reese? To the right. And where are the negative numbers? To the left. So if you think about it as number lines, because that's what they are, you guys have a lot of background knowledge with number lines. You just have to remember which number line do you go on first. Which number line do we go on first? Cam? Because it's which one? What do we call it? It is the horizontal one, Brady. The x-axis. What's the other one called? The y-axis. How can I remember that I go along the x-axis first? Maya? Yeah, x comes before y in the alphabet. The x coordinate comes before the y coordinate on a coordinate plane. Okay, so we're just going to jump into some examples because, again, we already have some background knowledge here. It says use this for questions A through D. So we're going to come down here. Give the ordered pair for point D. Point D. Who thinks they can give me the ordered pair for that? Remember, we have to go along the x-axis first and then the y-axis. So if I start at 0, 0, how far over, left or right, do I have to go to get to D? Emmett? What? How far over? I have to go over 0. So my first number is 0 because I go over 0 and then I go up 4. 4. What will that number be?
4.
Positive 4. So my ordered pair is just 0, 4. What about to get to E? Bryson, if I'm starting at the origin, how do I get to E?
Go over twice.
Okay.
To the right.
So I need 2 numbers to show that. So I go to the right 2, so I'm at 0, and if I move to the right, am I moving to positive numbers or negative numbers?
Positive.
Okay, so I go over how many?
Twice.
Over positive 2, and then how far up do I go?
0.
0. So most points are in a quadrant, one of the 4 quadrants. Those 2 aren't in a quadrant. Why not? Maya? Yeah, we would just say their location. If it asks what quadrant they're in, they're not in any of the quadrants. They're on the x-axis and the y-axis. Why do you think those things are called quadrants? Brady?
Because they're separated into 4 parts.
4 parts. What does the prefix quad mean? Emmett?
4.
4. Yeah, it means it's split into 4 parts. That's why they're called quadrants. And there is some things that you're going to learn about the quadrants. Quadrant 1 is all positive numbers. Always, because to get there you have to go to the right and up. To get anywhere in quadrant 1, I'd have to move from the origin right and up. Quadrant 2, I'd always have to move left to get there and up. So the ordered pairs in quadrant 2 will always be a negative number and then a positive number. How will I have to move to get to quadrant 3? Brady? Down and left. Down on a number line is negative. Left on a number line is negative. So that one would be 2 negatives. And for quadrant 4, you'd have to move to the right and down. So it'd be positive, negative. So you can tell just by looking at an ordered pair, when you get good at these, which quadrant it should be in if you graph it correctly. Who thinks they can give me the ordered pair for F? Remember, we move left or right first and then up or down. Reese? F.
Oh, F?
Yeah.
Oh, you go over 1 time?
So we go to the left 1. What number tells me to move left 1?
-1.
-1. Okay. Comma.
And then you go down 4, so -4.
Good job. -1, -4. The last one down there, I'm not going to move my board, is letter G. Who thinks they can give me G? Caden?
Go to -4.
Uh-huh.
Go down.
Okay, so what would my ordered pair be?
-4
Good job.
and -1.
Good job. -4, -1. Why do you think people get F and G ordered pairs confused? Briley?
Because I forget which and the X line.
Yep. Remember, you always move left or right first. That's the easiest way to remember. You got to move over before you go up or down. Now, part B says give the quadrant for the part for each point. So looking at D, what did we say? What quadrant is D in, Emmett?
Y and X.
No.
1, 4.
Abby.
Quadrant 1.
It's not in a quadrant. It's a trick question. Emma.
It's on the Y-axis.
It's on the y-axis. So if it asks for the quadrant, there isn't one. We just write y-axis.
I was correct.
You said xy. What about point E? Maya? It's on the x-axis. What about point F and G, really? F and G. Emma? Quadrant 3. And we can just put, I'm going to put a big Q. And usually they're with Roman numerals. You could put a 3 next to it also. Now, with the quadrants, notice how how they're listed. It starts with quadrant 1, which we can all find quadrant 1 because that's the one we're used to doing. And then it goes counterclockwise, which means backwards from a clock. So it's quadrant 1, and then it goes to quadrant 2, 3, 4, till you get back to 1. So quadrant 1, 2, 3, and 4. Emmett.
Maybe because you say Y, X axis, so Y, and then you go around.
That's just the way it is. In 7th grade, you'll talk about moving shapes clockwise or counterclockwise and naming the quadrants. They're just counterclockwise. Plot the following points. Who can tell me how to get to 5, -4? 5, -4. Kinley, how can we get to 5, -4?
You go over 5.
So we start at the origin, okay? We go right 5.
And then up negative.
Hold on, you just said up -4. What's weirder?
Down.
Down 4. So you go right 5, down 4. 1, 2, 3, 4. When you mark points, you put a dot, and then you label the dot with the appropriate letter. Brady.
Can I do the next one?
Okay, go ahead and give me 0, -3.
So you're on the origin.
Mm-hmm.
You just stay on the origin.
Yeah, because we go over 0 and then
You go
down to -3. Good job. And we're going to label that one with J. K, -3, 5. Caden, help me out. -3, 5.
So you go over to negative.
Hold on. Let's, instead of over, because over could mean different.
Left.
Okay, left, how many?
3.
1, 2, 3. Okay. And then what?
And then go up 5.
Up to 5. Good job. And we're going to put a dot there, and we're going to label that one with a K. Finley, what's the last one? I can't read mine. Mine's covered. L. How do I get to -2, -3? Finley?
Go on the origin.
Okay.
Then you go down.
We go left. Okay, there we go. Good job.
And then down 3.
Good job. And what are we calling that one? L? L. Okay. Tell which quadrant each point would be in. So it's not asking me to put these anywhere. Maya, if I was going to 4, 3, which quadrant would I end up in? Quadrant 1. How do you know that? Because they're both positive. And sometimes with these, even if you just visualize up coordinate plane, most of you can think, okay, I'd have to go over 4 and up 3. That would put me in quadrant 1. So that one is Q1. I'm going to do Roman numerals. -2, 5. Cam, where would that land us? Quadrant 2, because I'd have to go left and up, which would get me to quadrant 2. 5, -2. Lori, 5, -2. So if we start at the origin, 5 would take me to the right. Negative would take me down. So where would we end up? Quadrant 4. Do you guys know how to make a Roman numeral for 4?
Yes. It's 1V.
IV, yep. Yeah. Quadrant 4. What's the last one down there, Abby? -1, -1. If they're both negative, where are we at? Quadrant 3. Okay, so again, we have some background knowledge in that. And last year, we even kind of worked in all 4 quadrants a little bit. Okay, questions over that? Okay, now the next thing is brand new, but it goes along with statistics. Who remembers what are statistical questions? What are statistical questions? Paxton, you think you remember?
Like questions that it's questions that are like
Or can you give me an example of one?
it was 12 cars that walked me out at like 5 a.m. in the morning. Like at 5 p.m. there was only 6.
Okay, so the question would be how many cars are in the parking lot of St. Mary's Hospital each hour throughout the day? Because I could count, I could get a number for each thing. It's not a yes or no question. I could collect data from that question. Now, with that data, we can do lots of things. We can find mean, median, mode, and range. Can someone tell me what any of those things are? Brady, which one?
Isn't median is the middle number?
Median is the number in the middle when they are in order from least to greatest. Okay, good job. Median. Mode. What's mode of a set of numbers? Emmett? That sign won't be there. Maya?
It's like the one that occurs
Mode most. Yeah, which one occurs the most? Are there 7 sevens? That one probably occurs the most. What about mean or range? Who can tell me what the mean or the range is? Paxton?
Like, the mean is like the number that occurs the most.
Nope, mode is most. Briley?
Isn't the mean when you like add all the numbers up and then you divide it?
Yeah, it's the average. You add them up and divide by how many there are. So you add all the digits together. If there were 7 numbers, you'd divide it by 7. That gives you your average. Cam?
Like the biggest number divided by that.
So the range is the highest minus the lowest. The range in the numbers. Good job. Okay, so with box and whisker plots, they're called that because they look like this thing down here, this little pink thing. Like these are the whiskers. Oops. See the whiskers and the boxes? That sometimes they're called box plots, sometimes they're called box and whisker plots. The older you get, you'll do more stuff with them. In 6th grade, I really just have to teach you the basics about them and kind of what they mean and how to read them. So on box and whiskers, the only numbers that are important in the data sets are medians and minimum and maximum. What do you think the minimum and maximum numbers are?
Minimum is like the least.
The lowest number?
Lowest that you can get. Maximum is the highest you can
Yeah, so let's go ahead. Minimum is the lowest number. Let's go ahead and add that in. Again, that's kind of common knowledge, but minimum is the lowest number. Maximum is the highest number. And this is kind of like in a data set, which means a statistical question has been asked and data has been collected. Okay, so these things are made from statistical data that has been collected from a statistical question. And we said the median of a set of numbers is what? What is the median? Kendall? The middle number when they're in order from least to greatest. So middle number when in order from L to G. Okay, and then it shows you an example of a box plot. And this one specifically says this is Zach's step counter tracked how many steps he took each day for a week. Okay, so how many numbers do you think were in his data set? If it's counted every day for a week. Kendall? 7. Okay? Just by looking, what do you think the minimum number of steps he took in that week was? What do you think the minimum number of steps he took in that week was, Lena?
1,000.
Here's 1,000 would be like right here. Look at our box plot. Where's the lowest number, do you think?
Right between like 2,000 and 4,000.
Okay, what numbers between 2,000 and 4,000?
3,000.
3,000. So on one of the days, he took 3,000 steps. That was the least amount of steps that he took in that week. What day, or sorry, not what day, what was his highest number of steps? Caden? 10,000. Okay, so you guys know enough about graphs that you could probably pick out the minimum and the maximum if you have a little bit of background knowledge. Okay? Now, the boxes are created by medians, 3 different medians. Before we go any further, I want to make sure I point out something. That the boxes, I want you to make kind of a note here. The boxes represent half of the data points. I'm not very good at making those things, okay? So half of the data is between the 2 boxes. Your box includes half of the data. So what do you think the whiskers represent, these little whiskers here? If all of it is the whole amount. Briley? So from whisker to whisker, it's all of the data. The boxes are half of it. So what do you think each whisker is worth? Maya? A quarter. Okay, so this is worth 1/4 of the data. And this one is worth 1/4 of the data. Sometimes they will ask us questions just like that. It'll show the box and say between this number and this number, how much of the data does that represent? And if it's the boxes, it's half. If it's half the box,
Then it's half the box.
what's half of half?
Half of half is 1/4.
1/4, yeah. Okay, and we're going to get to some of those questions. Again, I'm just trying to expose you to different questions. Okay, so I'm going to start with quartile 2. Okay, quartile 2 is the overall median of the data. The overall median of the data. So right here, I want you to write overall median of the data. Okay, and it is the middle line of the box. So I'm going to go right here, and I want you to label that Q2, quartile 2. It's always that middle line of the box. And notice, is it in the middle of the box? No. Because it depends on where his steps were. It's just the median of all of the data. It's just a number smack dab in the middle of all of his data. Now, to the left of that, what do you think that is? The rest of the box to the left. Briley?
That's how much you put it on.
Well, which of these do you think it is? Quartile 1 or quartile 3? The lower quartile or the upper quartile? Lower, because it's getting smaller. Okay? So this right here we call our Q1. That's a Q. Or the lower quartile. It is the median of the lower half of the data. And again, in 6th grade, you don't have to draw these. You just kind of have to understand where the numbers are coming from. It's another median. Okay, it's the median of the lower half of the data, meaning when you have a set of numbers, you find the number in the middle, you circle it, that just splits your data set into 2. And then you find the median of this side, you find the median of that side. So what do you think quartile 3 is? Emmett?
Overall median of the upper data.
Yeah, it's the overall median of the upper half of the data, and it's represented by that line right there. The boxes are the quartiles, 1, 2, and 3. So it is the median of the upper half, median of upper half of data. Now, this word, if you think about it, what do you think the interquartile range is? Interquartile range. What does inter mean? Inside, quartiles, and range. Emmett?
So the big box, the numbers between like the bigger pink box, like
Okay.
yeah.
And? It's not up there on that sign. Range, so we know range is high minus low. Interquartile range is slightly different. Reese, what do you think it is?
The whisker on the left to the whisker on the right?
That would be the range of the whole set of data, would be the minimum or the maximum minus the minimum, would be the range of all of the data. This is IQR, which is inside the quartile range. Brady?
Inside the box.
Inside the boxes. So really, if we're looking at letters up here, we're doing Q3 minus Q1, which is the edge of our boxes. Subtract the edge of our boxes. That's our interquartile range. Okay, and again, that's lots of information. Okay, we're just going to apply some of it because you'll see these aren't too terrible. So the next one, I kind of told you how to make one, but you'll never be asked to create a box and whisker plot in 6th grade. So it says find the overall median, identify the minimum and the maximum, find the median of the lower quartile, find the median of the upper quartile. So it's a lot of just finding the middle numbers. Let's go to this question. This is kind of the questions that you might see in 6th grade. Cora got a new pedometer. It keeps track of how many steps she walks each day. Which box plot represents the data? Always start with your minimum and maximum because they're the easiest to figure out. Up there on our data chart, these are the recorded numbers. What is our minimum number? What is our minimum number, our smallest number up there, Maya? What? 5,500. I want you to circle that and write minimum above it, just M-I-N. Which one is the maximum? Briley? 9,000. Okay, so this one is our maximum number. Sometimes just that will knock one of them off. Let's go and check our minimum and maximum. Where am I looking to check my minimum and maximum numbers, Brant? Where do I look to find the minimum? And because these are, I'm trying to choose which one of these is correct. Where are the minimum and maximum numbers on those plots?
On the far side.
Far left, far right. So if I look, what do you notice about both of these? Kendall? Yeah, they both have the same minimum and same maximum. Could we say that that number right there is 5,500 and this one right here is 9,000 on both of them? So does that help me on this particular problem? No, but sometimes that'll be enough. One of them will have the wrong maximum or the wrong minimum, and you'll already have your guess. Okay? From there, we have to find the median. Before we can find the median, what do we need to do? Emma? Put them in order from least to greatest. You guys can do this right to the left over in this box. You guys have room. I'm going to do them vertical. If you would rather do them horizontal, that's fine. I just don't have room for that. I know my smallest one is 5,500. I know my biggest one is 9,000. I'm going to kind of check them as I write them. Which one would be my next smallest after 5,500? Pam?
6,600.
Yep, 6684. I'm going to write that here. 6684. Done with that one. What would come next? Paxton?
7316.
7316. Check. Next. Kendall? 7773. Check. Parker? 8227. Check. Lori?
8454.
8454. Check. Last one, Caden?
8546.
8546. Now, what do you notice about the Q? So we do minimum, maximum. That's what we check first. Then we go to Q2. I know it's weird. We go to Q2 first because that's the overall median. What do you notice about Q2 in both of these? What do you notice? Emmett?
The line is like lined up on the 8.
Yeah, it's right around 8,000 on both of them. So let's find our overall median. And remember, this is where we just use our fingers. I start at the minimum and maximum, and I work my way in. So I group those two, those two, those two. I have two medians. Who remembers what we do if we have two? And again, we don't have to do the actual math here. Reese, what would we do? You don't subtract them, you average them. How do I average two numbers? Brady?
Add them and then divide by 2.
Add them and divide by 2. If I took 7,700 and 8,200 and divided it by 2, do you guys agree I would get something around 8,000? Yeah, because it would be kind of between those two numbers. So we're going to just say about 8,000. Because we don't have to know specifics, but these ones agree, so I'm not too worried about that. Now, to find the median of the lower quartile. Okay, when I do that, that just kind of split my data sets in half. See how it split that set and this set? How could I find the median of the lower set? How could I find the median of the lower set? What's a median?
The middle.
The number in the middle. So I do the same thing, except I just start from here. So now I'm focusing on these two. What's a number between about 6,600 and 7,300? Paxton, what's kind of in the middle of those two?
Like
6,000?
Wait. No.
About 7,000. Do you guys agree with that? So let's check here. What is this one at? That's at about 7,500. This one is about 7,000. Which one would be between 66 and 73? Reese? The 7,000. So that's the one that would tell us that this one is out. Sorry, I shouldn't have put a star by it. We'll just put an X over it. That one's out because of that number right there. Now, we could go ahead and check the other one. Okay, if we're finding the median of this side, I'm looking for a number between 8,454 and 8,546. What's kind of right between those two? About 8,500. Is this at about 8,500? Yeah, and so is that one. So the only number that would have told us this one was off would have been that 7,500 right there. So this one, and again, that was a hard one to start with. I started with the hardest. Okay, but you're just finding numbers in the middle the whole time. Let's look at the next one. Miss Armstrong's 3rd grade class is learning about graphs. They made a graph showing how many baby teeth each student had lost. Which box plot represents the data? Let's kind of make a checklist for you just because this is new. When we're checking these, what do we check for first? What's kind of our checklist to go through? Emma?
Find the median first.
Not the median first. Maya?
The maximum.
Yeah, check the minimum and maximum. So we're going to make this outside. Minimum, then maximum, then what? Then what do we check? Maya?
Put them in the.
Then we find the overall median. What do we call that in these? The overall median. What? Nope, not the interquartile range. What do we call the overall median? Which Q is it? 1, 2, or 3?
4. No. 1.
This is important. Emma? Q2, which is the overall median, and then we can check Q1, Q3. The order doesn't really matter. Okay, and just looking at this one, our minimum here is 4. Our minimum here is what? 3. So just the minimum and maximum should give us our answer here. What is the minimum number?
3.
What's our lowest number in our teeth lost? 3. 3 is our minimum. So that means it would have to be that one, because that one has our minimum of 4. That right there is what knocks us out. So on those ones, it's that easy. Okay, like I said, I gave you the hardest one first. Okay? Next one. When the track season started, Coach Calhoun recorded how long it took each athlete to run a mile. When the season ended, he measured their times again to see how the team improved. These box plots show the results. When was there more variation in the times? What does variation mean?
Like a different.
A difference in the times. Let's look at the start of the season. What was the highest time? 15 minutes, I'm assuming?
Yeah.
Okay, what was the lowest time?
13.
What's between 6 and 8?
7.
7. What's 15 minus 7? 8. So there was about a range or variation of 8 minutes. What about at the end of the season? What's our subtraction problem for the end of the season? Emma? 13 minus 6, which is what? 7. So again, they could ask us which one has more variation or less variation. Which one had more of a variety or more variation, Finley? So this one had a variation of 8. This one had a variation of 7 minutes. Which one was more? The start of the season. When the season started, there was more, the times varied more. Okay, so some of them are like that, where we just have to be able to read the box plots. Coach Coach Jennings recorded the number of goals the hockey team scored in each game last season. What was the most goals scored? What was the most goals the team scored in a game? Emmett. 8. How'd you come up with that?
Because it says it.
It doesn't say it. You have to know how to read a box plot.
But, like, it stretches to it.
Because that is the maximum number. Because we know that that whisker shows us the maximum number. Okay. So anytime it asks about fractions on box plots, your answer is going to be 1/4, 1/2, 3/4, and that's about the only options you can have. The Bayview Community Pool has a snack stand where Juan works part-time. He tracked his total sales during each shift last month. This box plot shows the results. What fraction of Julian's shift had total sales of $225 or more? Where is 225? Where is 225? Emma? I couldn't hear you because there's too many people moving around. What'd you say? Yeah, so I want everybody on this one to circle that piece right there. All of that represents 225 or more. 225 and up. What piece of the box plot did I circle? Emmett? What do we call that piece of it? Brant? The whisker. What fraction does one whisker represent of the data? 1/4. So this is just 1/4. We're going to finish this, so. Next one. The Cougars basketball team sold tins of flavored popcorn as a fundraiser. The players competed for prizes to see who could sell the most tins. This box plot shows the results. What fraction of the players sold between 8 and 16? So we're going to circle those numbers. Between 8 and 16. What did I circle? All of the what? All of the boxes represent how much of the data, Reese? Half. Good job. So half. Last one's just looking at it. What was the lower quartile of Addison's practice time? Which of those pieces represents my lower quartile, Brant? The left, not the whisker. The whisker is the minimum. Where the whisker starts. So this right here is our lower quartile. So it would be 70. Okay, now, do you know everything there is to know about box plots? No. But do you know a lot more than you knew yesterday? Yes. Okay, for homework. Do that second page. The front is very similar to our notes. There are 6 box plots on the back to try. Okay? Okay, you guys can go.